Hey friends, this tutorial deals with some of the basic concepts of hard disk, which is a secondary storage device. In this presentation we'll have a look at hard disks, some of its features like physical structure, storage capacity, transfer time, and from here we'll move on to see how data is organized in sectors, block structure of disks, and clusters and file systems. So to start on, what is hard disk? A hard disk drive is a data storage device used for storing and retrieving digital information using rapidly rotating disk platters. About platters we'll have a look later on. So platter is coated with magnetic material, and hard disk retains its data even when power is switched off. Data is read in random access manner, meaning individual blocks of data can be stored or retrieved in any order rather than just sequentially. An HDD consists of one or more rigid, rapidly rotating disk platters, we'll see about it later on, with magnetic heads on a moving actuator arm to read and write data to the surfaces. Platter has two surfaces, we'll have a look of it later on in the. Now let's see some of the hard disk properties. This diagram represents the physical layout of the hard disk. It consists of platters, as we spoke about. Platters are disks, and a hard disk is made up of many platters. A platter is further divided into tracks. Tracks, as we can see, concentric circles. These are tracks, and this sector is a part of a track, and even a part of a. The sector is a part of a track and even the part of the whole platter. We'll have a better look of it later on. So we'll see the physical structure and we'll discuss a bit. Hard disk consists of platters, as we saw. Platters consist of magnetic material magnetized to hold the data. So basically the data on this hard disk is stored in platters. Tracks are concentric circles on the surface of each platter, as you can see from this figure. The yellow ones depict the track. So these tracks record all the information stored on the hard disk. So these are responsible for holding the data. Tracks are further divided into sectors, as you can see from this gray sector. This is a sector of a track. The sectors can even be of a platter like this. This division shows the sectors of a platter, and this gray one shows the sector of a track. Tracks are the smallest addressable units in the hard disks, the basic units of platters or hard disk. Usually one disk has head to read or write data to disk storage. One for top and one for bottom. Thus head's pointer indicates the disk position and disk's top or bottom. Basically what happens is that there are two pointers, head and tail. One is to read and one is to write data to the disk. The head pointer can point to both the upper surface of the platter and to the lower surface of the platter. Thus the head pointer indicates the disk position and disk's top or bottom. Now there is another concept called cylinder. It represents the sectors of all the platters in a column. The cylinder refers to the conceptual idea of tracks that are accessible without moving the head pointer. As we'll see in the next slide, the number of cylinder in a hard disk is equal to the number of tracks on each surface. The next attribute of a hard disk is storage capacity. Hard disk is divided into cylinders, which are divided into tracks. tracks are further divided into sectors. These three components determine the data storage capacity. As we saw in the previous slide, this column represents the cylinder X, as in the other side here, and this is the sector, and this is track. These three attributes contribute to the.
See, when these circular plates are combined together, they give us an illusion that they look like a cylinder. That's why we are calling it cylinder.
So these three attributes determine the storage capacity. Formula for computing storage capacity is shown here. Storage capacity is equal to number of cylinders per disk into cylinder capacity. Cylinder capacity is further calculated as number of tracks per cylinder into track capacity, and track capacity is further computed as number of sectors per track into sector capacity. So this moves like a hierarchy. Now here we'll have a look at example to
understand the concept better. And to, so this problem is about, let's have a look at the problem. Calculate data transfer speed of hard disk if it has a speed of 1000 rpm. Rpm refers to rotations per minute, and has 170 sectors per track. Assume that a sector can store 512 bytes of data. So we are supposed to calculate the transfer speed. So we'll proceed as, now we know the rotations per minute, we know the speed of the disk, it's like 10,000 rotations per minute, and there are 170 sectors per track. So in one rotation it will read 170 sectors. So time to read one sector will be 170 sectors will be 1 by 10,000 minutes, and time to read one sector will be 1 by 170 into 60 by 10,000, that's rpm. So it will give us the time to read one sector. Now data transfer is the transfer of sector. I mean by transfer speed we mean the transfer of each sector, because a sector is the basic unit of data transfer. Since one sector contains 512 bytes, and we know that time to read one sector is 0.036 milliseconds, so we can calculate the transfer speed as data into time per sector, and this gives us 14.2 MB per second. Now the next attribute is transfer time. The time required to transfer 1 byte of data from track to read-write head is called transfer time. The expression for calculating transfer time is as we saw in the previous example. The process of reading or writing data to the hard disk really comprises two large steps. The work done by the drive itself measured by internal performance factors, and the interface. The internal work of the drive can itself be thought as two functions: finding the correct location on the drive and then reading the data. These are very different jobs, and two drives can be very similar in one regard but very different in another. The transfer time, we can explain this in a other fashion. Reading data to or from the hard disk follows the following pattern. First, the operating system sends control signals to disk through the disk driver to read or write data from or into a given sector of a given cylinder. So the first job which is done while reading or writing data or in the transfer process is the signal generated by the operating system, which sends our header to the given sector of a cylinder. The next disk is rotated to position the required sector under the read-write head. We rotate the disk is rotated, and the read-write header is placed
on the what to say on the concerned sector, and then the read write head moves to the required cylinder. Now while carrying out this process, there can be delays which we'll have a look at the next section. The first type of delay is seek time. What is seek time? This time taken by the head pointer to move to the required cylinder is called seek time. So as we saw that the first step in transferring data is to send control signals to the disk through the disk driver to read or write data into a given sector of a given cylinder. So the time which head pointer takes to move to the required cylinder is called seek time, and its value is never more than 10 milliseconds, and this is fixed for a particular disk. The next type of delay is rotational delay. The time taken for a disk to rotate and bring the required sector under the head pointer. As we saw in the second step of transfer time or transfer procedure, the second process is that disk is rotated to position the required sector under the read and write head, and the time taken to process this is called rotational delay. Another interesting fact about rotational delay is that it is exactly half of the time taken for one rotation. The next is the transfer time, and it's simple: the time required to transfer 1 byte of data from track to the head pointer. From this expression we can calculate the transfer time, number of bytes transferred by number of bytes on track into rotation time. This is a simple formula to calculate the transfer time. Now we'll have a look as how the data is organized in sectors, or rather organized by sectors. So from this diagram we can further revise the concepts. These concentric circles on the platters represent the track, and the tracks in the column form the cylinder, and this shows the sector of a platter, or rather a track. In computer disk storage, a sector is a subdivision of a track on a magnetic disk or optical disk. Each sector stores a fixed amount of user data. We have discussed about this earlier also. Traditional formatting of this storage media provides space for 512 bytes or 2048 bytes of user accessible data per second. So this is the capacity of a sector. Newer hard drives use 4096. So we have in advanced format sectors the capacity is 4096 byte. Data is saved in physical sectors which are consecutive. Physical adjacent sectors need not be logically equivalent. We'll see this properly in the next section. What does this mean? Now from this figure, A represents a track, B represents the geometrical sector. Geometrical sector means it includes the sector of all the tracks on a platter. And the next one is track sector, a sector of a particular track. And D is cluster. We'll see about clusters properly. And cluster is a series of sectors. So data in hard disk is always stored in sector. Data is saved in Data is stored in consecutive physical sector, which makes them easy to access. Since the sectors are a very small size, means they can store only a limited amount of data like 512 bytes, and when a file is stored in sectors, individual sectors, it will be a very cumbersome task to manage all the sectors. So what we do is we store the data in physical sectors and then we club it together to form what is called clusters.
Yeah, and this section we'll be dealing in this next slide. See, while organizing the data, we see that data is stored on a particular sector, right?
and when the read write head moves over a particular sector, it reads it while it is on. See, if the two data are stored together, then it will be obviously easy to store to read it. So it's a preferable choice that we will keep the data on the consecutive sectors, right? But note the fact, after the read write head has finished reading, it needs some time to process. Obviously it is a machine and it needs some time to process also. And suppose if we'll put the data in two consecutive sectors, once it has finished reading a particular sector and it has moved to the next sector, it contains the same required data, right? So if just after reading the first data, we'll move on to the read write head will move on to the next sector, then we will rather miss certain important data. So to avoid this thing, we'll give an interleaving between the two sectors, and this interleaving can be adjusted by the system architecture. And
so what we saw is that when we move from one sector to other, the data is lost. So to avoid this, we'll avoid putting data in consecutive sectors and will have an approach of interleaving. So system designers have approached this problem by interleaving the sectors, which means that there will be no data is not stored in two consecutive sectors. Rather, we leave a sector and then we move on to the next one, alternate sectors or maybe more sectors in between. Now we'll have a look at the clusters and file systems. The smallest unit of space on the hard disk that any software program can access is a sector, consisting of 512 bytes. Another view of sector organization is maintained by computer operating system that we refer as file manager. So file manager is a thing which maintains the view of sector organization. File manager maps the logical paths of the file to their corresponding physical location. It does this by viewing the files as a series of cluster sectors. So we saw that the cluster is a series of sectors, and this is maintained by file manager. So file manager keeps all the information about the sectors or clusters basically containing the sectors. A cluster is a fixed number of contiguous sectors, as we spoke about. Once a given cluster has been found on the disk, all sectors in that cluster can be accessed without requiring any additional C. Since all the sectors in a cluster are addressed as one, so we don't have to take extra botheration to find the sectors. To view a file as a series of clusters and still maintain the sectored view, the file manager ties the logical sectors to the physical clusters. Clusters, they belong to using a file allocation table. So what is file allocation table? File allocation table is basically a list which maintains the record of all the clusters in the file. It has 5 components. The file allocation table has 5 components: the address of the next cluster in a chain, a special end of file character that indicates the end of a chain, a special character to mark a bad cluster, a special character to mark a reserved cluster, a 0 to indicate that cluster is unused. So we need not go in detail, but this FAT contains almost all the information about a cluster which handles a particular file. We'll have a look at the cluster. See, this cluster contains the 4 sectors, 1, 2, 3 and 4. So this is a cluster of 4 sectors, and sector, smallest storage space, 512 bytes, track of all the way around. This concentric circle is a track, and this is a read write head which does all the job of data transfer and data reading in a hard disk. So this was my presentation, a brief presentation to clear some of the concepts. I hope it will help you a little. Thanks a lot.